that as well. If
Oh, that's true. I don't mind. I got it running.
okay,
I'll start up there.
okay, great. So again, hello everyone. Welcome to today's session of Smart Contract Gladiator. Today we are going to see a lot of interesting stuff. We are going to investigate some transaction because in past couple of weeks we heard about these terms that we discussed about this term of read-only UTXO and the usage of this kind of UTXO that you will bring it into a transaction, but you do not spend it. And one of the job we talk about is the Oracle, but Steve actually brought this point out that Oracle is normally gets updated regularly, but what we at least right now implemented is kind of constant until it's necessary to get updated. So it's kind of a reference. So I changed the name to reference UTXO, but still it is the nature is kind of same. And in UTXO that you will put some information inside it, and you are going to use it in your smart contract, but you are not going to touch that information, at least in that specific transaction. And if you pull, I shared the link into chat, and we will share the link inside the description of the video as well. Please clone the repo, but just bear with me to. I want to explain the structure of this repo, so you will get you won't get lost. So if you can see there are these packages. By the way, the Bluetooth apps version is 1.1. I haven't updated to the newer version. I wanted to stay this version as a stable, and if the new version and the next version actually next develop on that new structure of the Bluetooth apps, and in this project file gets stable, I will change it. So for now, please follow what we used to with Nix and Bluetooth app and so on. So this is the version. Please check out this tag, and then when you see this folder, you are going to see some SCG, which is a standard for Export Contract Gladiator. And because we are going to expand this to different voting system, I thought that maybe we should start at the moment, because everything's kind of small, for a structure that we can scale it. So I just moved all the types to a different package called SCG types, all the script that's going to build datums and redeemer into a package called SCG JSON builder, and all the contracts inside this guy, this SCG contracts, and the compiler. But don't worry, it is just a very brief introduction. We're going to go through it. But the important thing is there is a folder called utils. And inside this folder, there is another two folders called, one of them is scripts and wallets. If you see and checking this repo right now, you are going to see that all these scripts are available, but the wallet folder is not available. The reason is I want you guys to come and participate in this charade, this system of voting and being the Caesar, senator, and so on. You are going to see it, but at least for them right at the moment, until some of you wants to participate and share in your PubKey hash. But if you don't know what's PubKey hash, don't worry, you are going to learn it. So until then, I just I created some wallets by help of a script called create wallet, which if you can run, let me show you how you can run it. So you will be able to run it as well. So if you come to this directory path in a script, and if you run the script, you are going to see this thing, like please enter the name of wallet. But don't do that. So don't run this script inside the script folder. It would be better, I made this a script so you can run it anywhere and the result comes into the folder you are going to create. So let's go, for example, outside, let's go to the wallets folder, and let's create a wallet called test. And double S, okay. Okay, sorry, let me change that. To test. For some reason, my S button, by the way, clicking double times. I don't know what's going on. So, sorry, we are in that. So, inside the folder, you are going to create these wallets. For example, Senator, Caesar, Arna Master, Gladiator, whatever. Just run the script. So the script path is double, get to double script and create wallet. And here, let's call the name of the wallet test. And here you have a choice to make these seed phrases 9, 15, 24. There are much more options actually with Cardano address or Cardano wallet tool, which this script is using. But currently, for some reason, which I don't know, browser wallets, even Dedalus, accept wallets that has this 9, 15, and 24 seed phrases. So if it is like 21 or it is the 12, they don't accept for some reason. I don't know why. So I just limited to what's happening with browser. So we just choose 15. And then we just save. So as you can see, this is the seed phrase, but this is just that's a script for learning mostly. So that's why it shows the recovery phrases. But if you want to use it for real stuff, some real things like mainnet, you can change the script, so you won't need to see this thing. So it would be much more secure. But yeah, this is the seed recovery phrases, those 15 words, and this is the root signing key, which is we can call it root address. It's all your address, billions of address, which can be derived from this one sentence of guy. And here it now is asking the payment address index. And for now, if you want to go with default address, which is the NAMI wallet, for example, just choose 0. But if you want to test some stuff, you can go with 2,147,480,000. I think, let me, 2,100,000, I think 600 something. Yeah. So you can have around 2 billion, 2 power 31 minus 1. That's a number of things you can go with this address. And inside this script, you can have different accounts as well. And each account can have 2 billion or something addresses. So you don't go that. I mean, if you want to go, fine, but your wallet will not be able to show to you. So I normally go with 1. Because when these files created by this script, I can recognize what's going on if I go with 00, because there is a stake address index as well. It would be confusing for me. So let's go for just 1, and we'll see this stuff here, and then it will ask us to choose the stake address. Normally, right now at the moment of the Cardano blockchain, we need only 1 stake address. But in future, when we have partial staking and other use cases for a stake address, we will go with a higher index. So just go with 0. If you want to use your address inside your browser wallet. By the way, if you are going to use Game Changer wallet, first of all, that they have much better UI than this script, and you can choose many things, and you can actually learn a lot of stuff there. But for now, this is the thing. And after choosing the 0 index, you are going to see the stuff that these are the stuff that this script is made by this command. If you list what was made, so as you can see, there is thing. And at the end, this is the address. Testnet delegation. And why it is testnet delegation? Because there are different terms for this address, but here I choose testnet delegation. It means an address, which as you can see here, consists of payment part and a staking part. And we need both of them inside our plan because this is the secure way. So we don't want to go with only payment, and this is the best practice. And we must actually get used to it to handle both parts, because you have no idea how many people just maybe escaped this part, and there was a lot of money stolen from people. So yeah, this is the big one, big address, which consists of 2 parts and inside the code, and we are going to learn. And I hope in future, I don't know when, but in future, we will talk about a staking part as a mean for voting, because in 1694, you have seen some staking stuff. So we're going to use something like this, and we might bring other contract like withdrawal and certifying into the game and plan too. So, but what address you need to build, you need to create, are these guys, these names, names, as you can see, that's RNA1 master, Caesar, debugger, governor. And don't care about this. It is for all the references about Senate and test. But you might say, okay, how should I know? What should I be? If you come to the SQL folder, there is a file called environment.conf configuration. And if you come down around like addresses, here addresses part, from here you can see, from here you can see these are referring to wallet path. So, sorry. If you want to go with different names, different stuff, it's fine. But you need to change these path here, because the scripts are using this path to do all those transaction building automatically. So just by looking at the environment file, at the address section, of course, payment pub key hash section, and payment signing key hash section, and payment verification key, you can get the idea what folder name, file name, wallet name you should be, and what are the things that. So if you follow these, you don't need to change anything here. Like if you follow, okay, Senator 1, Senator 2, 3, 4, 7, or Spectre. By the way, Spectre is going to vote. We are going to see that how this voting play out. But for now, it's just we call it. But I hope you guys will be the Spectre, even myself. So this is just for the testing and seeing how these things work out. So if you do not want to change stuff here, please follow the naming convention. And of course, if you have any suggestion or like better naming or something, please show us. So that's it. Let me just briefly talk about what did we talk about last few weeks. So then we will jump to the transaction before going through the codes, and then we have a lot of headache and question. So in next couple of hours, we will just try to solve and calm ourselves. That's the plan for today. So let's see how this works. So if you guys remember, there is this SVG file which I exported as well, but this looks bad here in the VS Code. But there is a good picture; we can see it on the repo. that a smart contract Gladiator design pattern. I updated the stuff there. So the idea is there is a Senate. But okay, let's before that, why we are using this? Well, eventually the whole purpose of this smart contract Gladiator, at least at the moment, for time being, we are going to build and implement different voting system completely on-chain. Because as far as you guys know, a lot of the stuff happening with this on-chain, the voting governance stuff, but mostly they are off-chain. There is some nice, beautiful front end that gives you options and doing for control your DAO, but there are not that much. There are not actually, maybe absolutely zero on-chain effect. But by on-chain effect, I mean not just recording a vote or something. No, the effect and the side effect of that voting. For example, if a voting here, let's I made it, and we are going to explore it in future. This is the voting system and the political system, actually, maybe we can call it, that we are going to implement. And these guys are going to vote, and the result of voting will be handled by the smart contract called Electoral Commission, and the result of that will be stored on the UTXO. And again, that UTXO and this smart contract will come and play a role into Arena, and they will decide the fate of a Gladiator, which all of them are a smart contract. So this concept of on-chain effect and kind of automatically, like really going through of code is law, so no one can do. But there are things beside that code is law is very limited, and even let's be honest, short-sighted maybe ideology, because right now codes of course can be law, but that law should be practical, that should be inclusive, not exclusive. And if the code is written with some program language, it will have just a limitation or so on. So this session, like a smart contract Gladiator and the system that we are trying to use, we are going to create this governance or voting system by help of code, of course, but mainly we are a research platform, a think tank or something. So this system of a smart contract that we are, all of us, going to think about it and making things happen and have effect on chain needs a system of a smart contract. And by the system of a smart contract, I mean something that we always say it, and even Gimbalab is kind of become a motto, that do not trust, verify. So the system of a smart contract I'm referring right now, at the moment, is a system of a smart contract that they verify each other. So there are different smart contracts, and they have different logic, they have different roles, but we need to verify them, and we do not want to trust that. So another limitation of code is law. Right now, you have to trust the code. So that's a bad thing, but you should verify it. That's why we are focusing on the building these stuff. So we will verify. If it is a law, okay, we will respect it, but let's verify it at first. Let's verify its code, let's verify its functionality, and let's verify its practicality for the job that was intended, that code was written to do that exact job. So the system I suggested is called role-based access control model, which you can just search it. What the hell is it? Role-based access control. It is a well-known control system in cybersecurity and designing for organization who wants to manage and organize the authentication and authorization stuff with their employees, even the system and so on. So this system, I talked with very details, and I went into depth in on previous videos. But if you have any questions, short, please raise your hand, and past. But that system, we changed its name, and some, of course, there are some modification happened to it. So right now we have this system that you are right now seeing, that there is a Senate, and this Senate is going to assign and designate governor. And governor is a pub key hash. Governor is an entity. It is an entity that going to designate gatekeeper. And the gatekeeper is a smart contract that holds some people. Like here is Arana master. There will be some admin. But admin and Arana master also the people who are going to act as a gatekeeper, they will use this smart contract. They will use gatekeeper a smart contract. To do what exactly? To do what will happen, and whatever will happen, we will decide inside the Arana. And in order to do that, we need to tell these each individual smart contract, these governor, these Arana master, every PubKey hash is going to have a role, should be authenticated to that smart contract. So Senate is going to mint a token, and it will put, I mean, we are going to see that. That Senate will be put that authentication token, or let's say call it governor of token inside the UTXO that holds the datum. And that datum holds PubKey hash of the governor and the session, the time of activity, how long this guy is going to be responsible or be a governor or have the power. And this is actually kind of accurate to history, thanks to Roberto. He stated that there was this stuff back in ancient Rome, that there was this Caesar, and this guy was kind of advisor. So the Senate was the person, the Senate was the entity that was assigning the governor, or let's say like prime minister or president or whatever that we have it in modern time. So this is it. So the Senate, the only role right now has is, I mean, we are going to see that as assigned governor. So with access control, which we can kind of think, okay, this is the government. Governor will use access control to assign different smart contract into the whole system. One thing I want to point out that you might say, okay, this is voting, this is access control, this is cybersecurity stuff. Maybe I want just to build a dApp. I don't want to go through this stuff. But my friend, please remember that when you are going to create your dApp, you don't want you want some flexibility, right? You want to update your system. You don't want to do something that is absolutely there. Of course, there is this immutability agenda and so on, but we can't discuss about it. But in order for you to have a flexible smart contract, and by that I mean you can update it, not the code, but like you can substitute it. It would be better term. Substitute your dApp a smart contract, and you want to have that control, and you want to have kind of kill switch into your dApp. So if something goes south, you cannot stop everything there and until the further notice. Of course, and again, this is very centralized. Wait a minute, this is you are creating this power to the business owner so they can do whatever they want. We are in blockchain. We should not do this. Of course, that's the whole purpose of this session. We especially introduce a person called Caesar, so you can really see, okay, there is an absolute dictator here. This system is a kind of mix of monarchy and oligarchy. Like the Senate is an oligarch people, that there are a bunch of people who are the seven pub cache, controlling everything. And of course, there is this monarch, which has some role, and we are going to see it. This guy has some control over this government too. This is bad. Yeah, but remember, right now we have, why I choose 7, because we have 7 keys on Cardano that's handling billions of ADA. So this is the current situation. And if you want to change it, let's think about it. Let's think that how should we do it with this smart contract? Let's democratize it. Let's make it possible that in future, if we want to go with the governance like Cody's law or something, anything, we have a roadmap. So if you are going to create your DApp, your DAO, your business, all these things that you are going to do in blockchain, here is the place to test them out. Here's the place that to see that, oh, there is this issue with it. We don't want to do that. Oh, this is custodial. Oh, that is non-custodial. That is better. So here, by this design, which has so many flaws, so many loopholes, so many issues, we are testing and we are learning together. So that's it. There are, of course, more details that we discussed about them much in details in previous videos. But if you have any question, please ask. Otherwise, I'm going to start the process. So, by the way, I won't go too far and too deep. I will today. I hope we will be reach until the gatekeeper, because there are things that we need. I want to break down, so it will take time. But yeah, if you have any question, please raise your hands. If not, let's do this script. Let's jump in how this system works. So I see no hands. So okay. So there is another file called, I call it here in this dark folder, I call that a system initialization process. And by that means that there are some steps that you can see. I put a 1, 2, 3, 4, 5, 6, 6. And today if we are lucky, we will go with the 7 and 8, kinda. But I hope we will finish, because as you can see, this even the 6, and I really summarize them. There are a lot of happening inside, a lot of stuff happening inside them, but I just summarize them. But if you want to play around with this system, this system, this is the starting. Like also, I made this script by the number, so you can follow the number by that. But in future, when we implement these voting system and these Gladiator and so on, I don't think we will follow these numbers. So I just wanted to make this so it will be at like a history inside the GitLab. We can actually refer it. But the thing is, for starting this series, first you need to compile the whole structure, the whole already code, all this code that, as I said, inside the contracts. For today, we don't touch voting system and the proxy, which is the Arana contract, and this one, the Arana Gladiator authentication token, which will be authenticate gladiators inside the Arana. We won't touch them. It's like, if you see their code, it's just a bunch of something. It's actually, or Arana doesn't mean anything. It's just always succeed. And even in electoral commission or tug of war, again, as you can see, these are just like a placeholder. So we won't touch them. We don't need them at the moment. But in order to compile the whole purpose, I made a script called write all, and it is located inside SCG compiler inside SCR write all. So in order to run it, after having your Nix shell, even Nix develop, I haven't tested there, to be honest, but maybe it will work there as well. I think it will work fine. But anyway, if you have the Nix shell, come to this path, this directory path, smart contract Gladiator and SCG compiler, and of course go with Cabal repel. And but if for the first time, of course, please go with Cabal update. Sorry, I forgot. Cabal update at first command if you clone in this repo, but then go with Cabal repel. By the way, you can go Cabal update at the root directory. You don't need to go with like a subdirectory, but it will be same. Don't worry. But anyway, after updating, everything's fine. Go with Cabal repel, and this will compile stuff there. Like the full compile, that's like it will just make it an example compile that everything is fine. Like there is no error, there is no type error, and so on. But when everything is fine, you can. I hope you will end up with this write all. So we will end up to this script, and this script is not doing something special. It's just calling other function based on the sequence. This sequence, this canonical order is important because, as you could see here in the system, that we are starting from top. Like by the top, or let's say not top, let's call it from left side. And then we will compile by the compilation, by the way, we will compile to right side. So it's happening exactly like this. So if I can make this maybe bigger even, it's become so big.
Mix.
Go ahead, Martin.
So you have to set up, of course, your development environment to run the Cardano node for this, right?
The Cardano node, yeah, of course. I mean, I'm sorry, Martin, but I'm assuming that you have your development environment already. You have your nodes already. If you do not have your nodes, don't worry. This script will warn you. This script, each and individual, all of them, at the first command is check process. It's Cardano node. So if you do not have node, you cannot run it at all. It doesn't run. But what the hell is node? You have to run. So go ahead. Sorry.
Where can you find the on NixOS? What is the best place to look for installing this Cardano?
I don't have NixOS. I have Mint. You don't need NixOS, my friend. You just Nix shell. Like if you let me like this. Let's go from the beginning then. Okay. So clone the Bluetooth apps, then run Nix shell. And of course, Bluetooth apps cloning, it is a process. We covered that on Bluetooth project-based learning, but you might run these stuff inside the Demeter run as well. But I should warn you that because there are so many smart contracts here, in some cases we are going to see 3, and in future actually we are going to see much more. Your usage unit will be used very quickly. But again, this is the process that was covered in Bluetooth project-based learning, how you do that.
Yeah.
But if you have these Bluetooth apps, if you change, there is this stuff there that let me remember, where was it exactly? Cat etc, if I remember it correctly, etc nix and nix config. Yeah, if you have this nix config file ready, like this guy, especially these annoying things, please add these in your Nix file so you won't get annoyed so much. But what is flag and so on, that's a longer story. But anyway, if you have this guy and if you run Nix shell, it won't take that much time until you will reach your Nix shell. And when you have your Nix shell, please head to the directory that you clone that a smart contract Gladiator repo, and then inside there run cabal update, and then inside that after the cabal update run cabal repel. By the way, I don't think cabal build will work for some reason that I actually don't know right now. So let's do exactly this, what I said. Let's cd gimbal app, the smart contract Gladiator here, the cabal update. For me, it's fine. Actually, I don't want to run it because maybe it downloads something. I don't want my connection become worse than what it is right now. So I will just go with the cabal repel. But again, if you have any question about that, you can of course raise an issue in the exact repo, or do some pull requests, or tag me or read me in the Discord. So yeah, I'm available. Don't worry. But by the way, next week I don't think I would be available. You know, in Iran there is this New Year. You know, we have different calendars, so we have New Year happening in next week. So I'm not sure I will be available, but I will let you guys know that if I'm not available for next week. Anyway, cd compiler cabal repel. And after that, just call this function write all. So inside the write all file, a script called write all, and it will compile, write, create everything that you need for this system automatically. But if you want to go into the details, what is this, what they are doing, who's doing what, sure, of course, first you can come to the compiler, for example, looking at RNA1 and see like a gatekeeper. Oh, a gatekeeper, one of its contract parameter is access control validator hash. Another is currency symbol of RNA1 domain authentication token, or for the RNA1 domain authentication token, it is a contract. One of the contract parameter is the access control, and here is the where is it for the governance access control. One of its contract parameter is Senate. But by the way, as you can see, there are pub key hashes hard coded here, and that if you create those senators, Senate, you need to come to this guy to it here. But I know this is a long process. If you want to do that, I will help you on that. Don't worry. But if you are familiar with this stuff, no problem. But just remember that after finishing creating all these wallets, you need to change these stuff there. So I'm not sure actually. I can actually share everything here. Maybe I will discuss it with James. I will push everything here as well, because all these wallets. No one can, except you can take all the information there. But the problem is if for example, if I'm testing with these wallets, if you are testing that UTXO will create some issue, and you might see wait a minute, who's this guy, who's that guy. So I recommend to do that, but after creating your wallet, you need to come to this space. I remember now, I forgot that. Sorry about this. That you need to change these pub key hashes. For this senator, you need to change it. For Caesar, of course, and of course, debug. And inside the JSON file, JSON builder folder, you need to go to the, like for example, gatekeeper, to change the minister admin. Sorry, this is the wrong minter. It's not the minter. It should be undertaker. Undertaker job, the admin going to be fun. He's the guy that's going to collect the body of Gladiator. But what I mean that this guy is going to take the UTXO that's going to be used for activating Gladiator smart contract. So it's kind of undertaken. But anyway, this pop key hash and so on, I hope I will write a nice guide or something written so you can follow that. But if you are watching right now, please check compiler files and the JSON files inside the JSON builder. And if you see some string like this, please change it accordingly. Like if you made RNA master, just find the RNA master for the pop key hash, which will be this guy, the RNA1 master.1.payment.pop key hash, and copy this guy, paste it here, or for other stuff as well. I haven't found a way to automate this. Maybe there is a way. If you know, sure, please tell me, or even better, doing that like by pull request or something. But yeah, also inside the validator, there is this issue of a conflict of package. I cannot import compiler into the JSON and import JSON to compiler, because inside the compiler I had to put this JSON, this redeemer and datum to calculate contract execution budget. So this is the issue with many languages actually, that you cannot do import into each other. There are some dirty and ugly workaround that. So, but anyway, I decided just to create same thing happening in compiler called validator inside it. And yeah, but just to, if you come please here, change the debugger. I'm using one debugger for all the contract, senators, of course, popkey hash and Caesar. So yeah, and so again, sorry, I forgot about that to tell you, but please do that. And once you do that, and once you have all your file, and when everything is here is okay, we can you can just check the dist folder, and inside this folder you're going to see these contracts inside the build contracts, and inside data you are going to see 4 folder. I mean, the transaction you will see it future, but it is a placeholder for transaction CBOR as well. That when you create a transaction by this script, their file, output file, and will be here. It would be really great experience to just decode this CBOR. There are just a bunch of CBOR code and going through what there is happening inside it. But and core are the Plutus core of all these contracts. For some reason, I don't know why, minting contracts shows in one line, but if I go, for example, with a spending contract, everything like shows at least it is nicely. So and there are not that much formatter right now. But anyway, this is a purified, it is a human readable for that also, but the raw type also there, so you can just look at what's going on. This raw untyped Plutus core is the one actually live on chain. This is the one get converted to, for example, this is the raw for access control. This code you see is weird, this doesn't make sense at all, will be converted to binary and the CBOR, so this will be the one. And that's exactly the process that they had to take, that they had to compress this to this one. So this is just for knowledge, but we will maybe touch around it. But in Plutus project-based learning, in module 300, we will go much deeper into this stuff. And the datum as well, you can just look at the datum, what is this datum or so on. But let's just now jump into the transaction if you have any question. And again, I know this is sound confusing, but please, and I know I am sound confusing, you know, I maybe talk too much. I'm actually not talking even good, but fast, or not fast even. so not fast in a good way. So I know that I'm making a lot of confusion point for you, but please tolerate this and bear in mind that these terms, these stuff that's happening here, all of them, you will get used to it. All these terms become usual to you, and then you will, when you want to design your dApp, and doesn't matter you're a developer or not, when you want to design your dApp, you know what tools are, what process are, what method are, what methodology you need to use to create your dApp. So like if you want to hire a developer and say, hey, please create this NFT marketplace a smart contract for me, or this withdrawing or staking or whatever, you know that you know what you want from that developer. Like, hey, do this, it should handle this part, it should run with this Oracle, or so on, so forth. So just please bear with me about this complex stuff, and you will learn it. Don't worry. So again, as I said, the whole purpose of this compilation is to create all this stuff from left to right. But we will use the hash of these contracts, like gatekeeper, RNA, like as you saw inside the JSON, there were some information about the governor, like here in the access control to JSON. There is this information about governor. There is information about emperor treasury, republic treasury, and we are going to see what are the rules are. But role and rules are actually. But all these hash actually coming from right to left. Well, can I change the direction of this? Anyway, just I think there was something. Oh, yeah. So the kind of, we can call that the hardware, the smart contracts. That's going to be constant. We don't want to change it, right? We don't. It is immutable. It is unchanged. We don't want to change that. The compilation happened from left to right. It is the hardware. We don't change it. But the software, which are the hashes, for example, all these processes here, you want to change it. You want new gatekeeper. You want new proxy. You want to add new one. You want to update. All these happening from right to left. For example, if in your organization, an employee on department is changing, sure, nothing bad happened to your whole organization, just a one person, but it is at the bottom of organization. Same thing, if you want to change this a smart contract, the proxy or the gatekeeper, your whole structure of the app shouldn't collapse. So that's the thing that we will go for from left to right as a hardware, and right to left for giving and creating these hashes and datum and so on as a software. And then we will apply this information as a reference UTXO, a UTXO that we are not going to spend, but we are just going to put this information, and what information? Let's look at that here actually. Inside this data, datum and access control, the reference UTXO for access control holds all the information. If you see, there is a file called access control ref UTXO datum. It's a big datum. And you see that right as you saw that we have, actually we have four domain. One of them is Colosseum, but that's under construction right now. But anyway, we have right now 4 RNA. That's 3 RNA, but it is 4 RNA. Let's call it 4 RNA. Never mind. 4 RNA, but you see that inside the data we have all these hashes. These are hashes of the contract inside your dApp, inside your project, which you are going to add and update. You won't need to use them as a contract parameter. So if something change, your whole contract must change as well. You don't need to do that by this system. So this reference right now consists of two parts. Yeah, this is the address for Republic Treasury. This is the address for Emperor Treasury, and these are the hashes for Gatekeeper, RNA, dominant authentication, all the things happening inside one domain. And as you guess, we have 4 domains, so 4 hashes. So if you want to make this flexible, this is the way. And there are bad things, there are drawbacks, of course, disadvantage. We can talk about it, and we will discover it actually as well about this system. But at least this system gives us this flexibility, this ability to change those smart contracts at the right side, at the place that user will interact. For example, let's say that these are a smart contract right now, but your RNA proxy can be the front a smart contract that the user will drop their UTXO there, they will interact with it at everything. This is the one user interact, but everything behind that, no, user doesn't need to know about them at all. And you might change it. You might make the your project version 1 now, project version 2 and 3. We can just change that simply by this design. Also, there is another stuff about the app wallet that we discussed in previous video, but app wallet, which is a bot, that is a robot that's handling the stuff. And if you want to use that, this system can make that interaction of app wallet secure. And you don't want to trust them again. As you don't want to trust. You need to verify. So without further ado, let's jump to the script. But as I showed you before, there is this process. There is this process of a script. Like when you want to start your organization, your DAO, whatever, first, and even in the government, first thing they do is creating the council of revolutionaries or Republican, or who's like a founding father. This is the one. This is the first step of your DAO. And in your DAO, remember that at least at the moment, you need to have these pub key hashes, because this is in the protocol level. I know it's bad, it's not the ideal level, but even in protocol level, as I said, in Cardano, not only Cardano, Ethereum, just Bitcoin, actually my knowledge, no, I don't know, maybe Bitcoin, but it's proof of work, maybe it doesn't have at all. But even in the Ethereum or in other blockchain, there is this Genesis keys. They call it Genesis keys, or the first 7 keys, or the 7, 7 is kind of a holy number. It gets repeated all the time in religion, nature, and so on. So let's go with 7. Cardano went with 7 as well. As I heard, by the way, I don't know. I'm not sure that it is 7, but I heard it is 7 keys, Genesis key. So your DApp needs 7 Genesis key, for example. And who are the team member? I don't know who's holding your DApp, who are the beneficiaries. So the first step is initiating this council, these senate, these whatever you call it. And let's run it. So if you look to the script, if you just forget about what's happening with that, the important part is transaction building, and it is just doing that using the Republic wallet, Republic Treasury wallet, to create these reference script, to put this contract, to make this contract happen, and like deploy it. And deploy means taking this contract, putting a UTXO, and sending back UTXO to the same wallet, the same treasury. So after this step, the contract is on-chain. So people can find it, we can use it, and so on. We will use it. So this is the transaction. It is not that much complex or something. But you might say, wait a minute, this is complex already. But no, don't worry. After maybe 20 minutes, you will laugh to this command because you are going to see something. And in the future weeks, you will laugh to the most difficult or most complex transaction that I'm going to show you today. Yeah, we are going to have a lot of fun with this stuff. And don't worry again, I've tried my best to break these things down. So yeah, this is the only thing that's it will use Republic Treasury wallet to create UTXO and deploy that contract, Senate contract inside that UTXO and sending back to Koja to where to TXL to Republic Treasury address again. But you might see there are two stuff here, two commands here exactly same. Well, I use a trick. The trick is I'm giving very low minimum UTXO to get an error. And the funny things, let me show you actually that if I just run this script at the moment, like I just commented everything, and I want to show you, if you want to build this and you do not have enough sufficient UTXO, let's see what error will show. So I think the node is running, great. Let's head back to the script. So see the script. Let's go for the first one. Create Senate reference script UTXO. And you'll see that this is happening all automatically. These are the UTXO inside the Republic wallet. But as you can see, if you see that I purposefully, as I said, I put one ADA as a like it should hold this contract. In Cardano, they choose that if you want to use a UTXO as your contract, you have to pay the price. So it means that if you have bigger contract, you have to pay more. And if you have less contract, of course, a smaller contract, you will pay less. So here, a script size will be important. And you have to pay. But the good thing is you will pay it once and it will be locked. So it will be not gone, but it will be locked. And if you send it to your wallet or even to a smart contract, which you're going to see that example, you can stake it. So it's kind of, you can use that UTXO. But again, you have to lock it. And as you can see inside the error, but I don't know, I don't know, the size of the script was very variable. And I didn't want to put hundreds, like constant number for all the contract, whether the contract was a small or big. So this is the trick I came up with, that I throw very low amount and the Cardano CLI gave me the exact Lovelace, exact ADA that's this smart contract needs to lock it. So that UTXO would be big enough to hold these big contract. How much big? So what are the limitation? The limitation is 72, 73 ADA as I tested. Sometimes I reached 74, but it was like if you do not put a token there, like if it is like pure UTXO without any datum, without any token, you can reach 74 something. This is my experience, by the way. But if you put a token there, if you put some datum there, your size will be less. So by this getting this error, we can get the exact number, and then here I use I use that exact error to feed same command next time. Next time it runs. So let me uncomment this, and you see that here I get the error out of it by these commands, and then I will get this minimum amount, and then the TX out will be the contract reference. TX out will be that, again, same thing, Republic Treasury address, which was here as well, but this time with the minimum amount, not 1 ADA. And now it works. So let's okay, I should this one. Okay, so let's run it and see it. So you see that after running that command and getting that error, I got that minimum amount, and now I said, hey, take this amount, send it back to the Republic Treasury address with Senate contract. Where is it? Here. With this with TXL reference script file. So this is simple. But I should remind you, please remember, I haven't write it down as a comment. Here I have two way to get a TX in a UTXO that's going to hold this stuff. Since Senate is the first one, and I'm using, I'm using also the Treasury, Republic Treasury for other contracts. And if Senate changes, it means the whole system must change, same like for any place. If some revolution happens somewhere, if the founding father changed, so now we have founding, I don't know, mothers. So now we have to have a Senate with mothers, not more fathers. Therefore, everything changed, okay? Then because of that, I'm going to spend all the UTXO inside it. So if you see that right now, as you could see that there were 5 UTXO here. But if I run these again, exactly same script, and it will query the Republic, you will see, okay, now it's 2. So please remember that these script will consume all the UTXO inside the Republic wallet, Republic Treasury wallet. But if you don't want to do that, you can just comment these and comment this guy out. It will just take, as it said, the biggest Lovelace, so it will not just consume everything. But it is, so I just wanted to point out. Okay, now we have the Senate. We deploy Senate contract. It is living on a UTXO. It is this guy, and even we can check them out. Let's see it. Let's see that. Let's go with the Cardano query. Okay, this is the big one. Okay, now I should find the address for the Republic Treasury here inside wallet, and inside the Republic Treasury folder. And there is a file called Republic the delegation address. And if I check it, if I just query the wallet, you see same stuff. Let me just clear the page. But if you just use this switch out file, and let's call it like temp.json or something. We can just call it temp. Doesn't matter. The extension doesn't matter. Just make this switch, so it will this command will put all the UTXO with all this. It's inside this file. And if we cat it, if we see what's content of this file is, we'll see that there is this UTXO that holds no datetone, no inline, but it holds this reference script. So this is the mean for deploying your smart contract. So if someone was asking you, or you want to ask a developer, hey, please deploy the contract, one way can be like this. Deploy contract on Cardano, it is like this. Inside the Cardano, it is like this. Like, but of course, it is different, completely different than Ethereum or in other places. So let's say we deploy it, and I see. Let me check the chat. By the way, I haven't checked the chat. Well, there were a lot of talks here. I'm sorry, I haven't checked it. I have Eris asked a question. I have a question. Who is this voting system mainly for? I mean, what kind? Let me bring the chat here. Can you? I don't know if you can see. No, you cannot see. It's weird that Zoom does not show itself. That it doesn't show its picture. Its windows. So. Eris asked, I have a question. Who is this voting system mainly for? I mean, what kind of group or organization do you have in mind as a target audience? Well, Eris right now, by the STV, I think asked or try to answer. I'm going to read that next. But the thing is, Eris, inside blockchain, everyone in all other blockchain, doesn't matter Cardano or whatever it is, they are saying, or they are exactly this what saying, sometimes even not trying, saying that they want to have decentralized organization. And it means they want to have this organization and they want to decentralize it. Okay, great. How do you want to manage this organization? By voting. That's the thing. Everyone are talking about that they want to implement some scheme of voting so they can manage this decentralized organization. What voting system? Well, we are here to investigate. Cardano proposed SIP 1694. There was EOS years back, and they proposed their governance, and that exact governance destroyed and ruined them completely. Because of the issue that the issue, they gave so much power to exchanges, so much power to people who had more EOS token. That's the thing. IOTA, Algorand, all of these guys are saying we want to implement a system that the community, people who has token, who has power, who has whatever, I mean, there are all this discussion, that they will decide about the fate of the organization. The biggest organization of a blockchain is the blockchain itself, the Cardano blockchain. But inside that, like Gimba Labs, Snaprilio, like our project Equival, every project that they are saying we are going to go make DAO, they want to have this voting system or this criteria, this agenda. So, but does this work? Is it a good idea? We really don't know. Let me be honest. Let me actually state that I'm not really a fan of this voting system, really. I'm not even really fan of Cody's law or whatever. Yeah, Cody's law is great in some, but it is not complete, to be honest. It's absolutely not. But so you might say, okay, you don't want voting system, you don't want, you want some monarchy, you want put dictatorship? No, I don't want. So you want oligarchy, same thing like happened with other systems, like even Cardano or Ethereum, like Vitalik and his buddy has these keys for these Ethereum maintenance and for the merge and purge and all those changes happening in Ethereum. They will share their keys, and there's a nice story about how he's hiding that keys or so on. This is oligarchy. We want to go with oligarchy. Bunch of people should decide about what your fund is. Well, we have already oligarchy, right? Even in capitalism, even in the other, like socialism, even in my country, we have all this oligarchy. That there is this part of group, they have their agenda, maybe they are fascist or not, they are religious or not, they believe in the ideology or not, doesn't matter. There is this bunch of people decide everything. So, okay, you don't want oligarchy, you don't want monarchy. I mean, if you are asking me, for example, and you don't want this democracy, this voting. So what would be the system? Well, the thing is, I'm with your help and with you, each of individual, all of you, I'm going to build it. We are going to build it. Something beside everything that we have tried it. Cardano, Charles Hoskinson, and the Cardano Foundation, they proposed that. But that SIP is not the end of the world. And that SIP is, of course, the first step. But that SIP has the issue. It has the issue of people, the stake pool or something. We don't know. Maybe there are some issues that we will discover. But the thing is, at the moment, and because of the pub key hash, and because of the protocol level, that the pub key hash, the wallets, the people who run this blockchain, who participate in blockchain, these pub key hashes are the one that running this blockchain. It's kind of a loop. It's like exactly like a loop. Therefore, the current proposal is let's go with voting, but based on what, who has more data, should have more power, voting power or not. And now that's open for discussion. So yeah, this is the trend. We are following that trend. We are trying to make in that voting system. If you want to build it in your ODAP, sure, welcome to do it. But my opinion is we need to come up with something better, something beyond that. You know, other day I was talking with A that the only science that wasn't improved in past couple of thousand years and until to this day is political science. People do not treat political as a science. It's kind of a religion, it's ideology, it's a sect, it's like philosophy. Even the philosophy is science, like it accept, but politics no. And that one of the things I personally think this is the thing that wrongs with the world is they do not treat politics as a science. They do not treat economy as science. Even. Let's imagine they think that they just repeat and repeat every problem, every issue that happened. But you might say they know it. They just don't want to change it. Okay. Now, I think we have enough technology, maybe with AI, maybe with some kind of different cybercracy system, we can build a system that there is no voting there, but it is fair, it is agile, it is robust, it is resilient to the attack, like propaganda attack, populism, all these attacks by people, the changes. But yeah, for at least for the first step, even for the first set of this small contract gladiator, we have implemented oligarchy and monarchy. And we are going to use democracy in future to just play a part, but we will try to destroy or adapt and enjoy it. Actually, there is a script. There is a script that can destroy, like the Caesar revoke access control, this guy. This guy is the one that a dictator loves to do it. What they will, if they see that there are people attacking him, what they do, what he do? He will just push the button and destroy the government. Like I don't know, like it is a self-destruct. It is a self-destruct script. And we are going to see what will happen. It's interesting script actually in terms of technicality. But yeah, this is it. It is bad, right? It is very bad. But guess what, Aris? I can maybe say 99% of all the dApps they are claiming, they have this. They have a key, they have some role that they put everything on that. And if that gets lost, if something happens, done, everything's done. And like this guy, like Sam Bankman-Fried, he made something, he did something, done. $7 billion is gone. So this is the current system we have. And the people who are trying to solve it, they said, let's remove this guy and like instead of having 7 POP-key hash plus 1 monarchy, or like 7 oligarchy POP-key hash plus 1 monarchy POP-key hash, let's go with like, I don't know, let's like 1 million POP-key hash. But still it is POP-key hash. Still there are people, get manipulated. There are social attacks, there are social engineers. What are the procedure or process to defend a system, blockchain? Like you are living in some corner of world, you are doing and you're minding your own business, but suddenly there is some news and suddenly 40% of the people who use Cardano get afraid. Oh, there is this something, FOMO, FUD, all these terms that is very well known. And whatever, you just woke up and say, wait a minute, where is everything? It's gone. They just get afraid because of a news, because of something. But there are these risks with this as well. But what else? What else we can do? This is the process. We are at the era or age that we are going to implement this and then finding its issue and then paying the price for these things, all these things. And then I hope we will survive and we will have enough strength to build something much better, which again, as I say, means personally, something that is not voting system, but is, as I say, it is fair, it is much better than that. How we can do it if we treat politics as a science, if we just doing that, a lot of problems will be solved. So sorry for this long answer, but how can we treat politics as a science? Well, I don't want to go with the terminology like what is science, but science, if it is science, let's just think about it as if it is science. There are no like prejudice or like there are some fanatic people inside. Of course, if there are people in science, like if you want to talk, Roberto, with someone, say like, hey, do you know there is this new theory in physics that said, you know what, gravity is not a force pulling Earth to sun or something. It is bending of a space-time. Yeah, that's the thing. If you say that, if it is science, they will give you Nobel Prize. They will give you Nobel Prize. They will give you money. They will say, wow, you changed the whole aspect of humanity. You've done great, maybe better than so many so-called religious figures because of this formula, because of this, because it is science. It's not just some fanatic ideology. But right now, if I say that, hey, I do not believe in democracy, just saying that. I do not believe in monarchy, oligarchy, democracy. I do not believe. I believe humanity inherently, because of their genetic, I don't know, because of environment, because of all the issues they're having in their mind, and the collective mind of that society, they will, I'm sorry for the language, okay, I won't use this language. They will ruin themselves unintentionally or intentionally. They will have always this vulnerability that some people, smart people or something, try to abuse it. And we have seen it throughout history and we are seeing it today. So let's build something that can help us. Like human cannot fly, so they build airplane. The human cannot swim underwater for long term. They build submarine or something. Let's build that. Let's build that. It is AI. No, maybe it is. I don't know. Maybe it is something else. Maybe. But that's the thing. If we treat it as a science, we can find the issue. We can talk about it. But if it is not science, we cannot even talk about it. We cannot criticize it. We cannot really going through the details. Even right now, Charles Hoskinson, I mean, if we talk about it, I don't know why I can't bet that. He might doesn't believe in all the voting system or whatever it is. But he would say that, you know what, how dare I can talk about it right now? If I just talk about, you know what, in Cardano, we don't want to go with voting system. We want to go with some new system that is, again, fair, everything is fine, and you don't need to vote, you don't need to worry, everything's fine, everything will be completely running smoothly, no problem. People will lose their shit and attack him, and attack, not him, they will attack his race, they will attack his religion, they will attack his beliefs, it's like, instead of even attacking to his word, instead of criticizing his word, they will try to kill or assassinate his character, his personality. That's the thing happen. If something, that's the issue. I believe this is that because it is not science, political. And yeah, A also respond very well that, yeah, quite scientific method, of course, exactly. But so I don't want to go to the conversation because when I go, I will lose my shit. You know, I talk too much, so I will lose some good stuff. So yeah, let me just. So okay, the second deployment. If you see where is it? The process. The second deployment is inside this system initialization purpose is initialization of area one. This is A1, stand for area 1, domain authentication token. And we are going to use this token to authenticate a smart contracts to other smart contracts. That's the things. We are going to put this token, authentication token, exactly in this, you know, there is this UTXO. This is a pure UTXO. There is a UTXO that holds just a script address and nothing else. But in after in the system, we are going to use these script reference inside reference UTXO. So there is a UTXO that holds a datum, and we are going to use that, and it holds a script as well. But how a smart contract can be sure that this is the actual reference, because this is the reference, right? This is the manual, this is the guide that a smart contract is going to use and decide all this verification afterward. Therefore, the job of this authentication token is to authenticate a smart contract. We will put this guy inside reference script and reference UTXO. By the way, reference UTXO for only this domain, because one thing that I've seen in some DAOs or some organization, even we have in the traditional organization, let's say there is a department, like the accounting department, something happened with accounting department. We don't want that fire that's happening, that crisis in that department, destroy the whole organization, right? Therefore, it would be better to treat everything in our DApp with domain. Like if you have a DAO, let's have a community for, like the community decide based on, of course, decide that, but the community can divide with different domain. So if something happens, if there is an attack, at least you can isolate that place, that domain. Therefore, by using this authentication token, if something happens, if something, you know, we are going to find out if something happens, you don't need to worry that other part of your DAO or your dApp will be affected, because the other part are using different authentication token. So yeah, this is as Ace said that well, don't expect me to spell that word. It's too big for me. Separation of concerns. He said that compartmentalization, something like this. So yeah, it's separation of concerns, exactly. Separation of concerns. So how do we do that on chain? How do we do that? By introducing domain-specific authentication token. So you're a smart contract. If they want to talk to each other, the first thing they will say to each other, hey, do you have this token or not? Do you have this ID or not? If you do not, sorry, I do not know you have. You are not welcome in this domain. By help of this, actually, you can introduce different admins, and those admins do not need to interfere with other people admin, other domain admin. But you might say, wait a minute, what if I have a DAO, I have a dApp that has 100 domain? Yeah, that's the issue. The role-based access control model, if you go through it, that's the issue. It's a scalability. It's a role when they become more and more people have it. What is the next level? There is something called, attribute access control model. But we won't go through that attribute-based access control. We won't go through that because I think we can go for something it is it is called next generation, but it is really I think will be great for DAOs and the voting or whatever governance we have, where all it's like it's a mesh. So this domain you see, all of the domains you see here, they will become mesh, a network. And if an admin from here, for example, Arna master from here comes to this mesh, comes to this forest, come to this area domain, whatever you call it, she can bring all its permission, authentication, authorization, whatever, and he can place some rule that you can define here as well. So you can have an app wallet. That's the beauty. You can have an app wallet which has a role inside this domain as an RNMS, as a witness for minting, for example. But same app wallet has another role inside another domain to do something else, completely this. So by this design, you can do this different authentication authorization of people. There are this like this mesh of people and the mesh of the DAG. And we can see this DAG. DAG is I always forget how to spell it. But anyway, this is kind of a mesh. So we are going to implement it, I hope, in future, because we are going to need it. I suspect when I was thinking about especially quadratic voting and SIP 1694, probably here, I'm not sure, but in quadratic voting, I think we will need it. So anyway, we will talk about it later. But right now, this is it. So then the next script that you need to run is the second one. Let's run it very quickly so we can just see that what will happen. It's again automatically will take care of everything. So now, but since we are going to use, we are using the same wallet, same Republic Treasury wallet, you guys need to wait a little bit, like 60 seconds, something to be safe. So you can again submit another transaction. I don't know, it is maybe do my network, maybe your network will be much faster, but just wait a little bit. So for running another script. So the next one is a smart contract it's going to handle creation and issuing of reference UTXO. The UTXO that's going to do what exactly? Authenticating of a smart contract. And inside that UTXO, there will be datum. And that datum is going to tell a smart contract what they should do, or they will introduce each other by this datum. If they have that datum, if they have that reference UTXO, okay, now everything's fine. Let's go back to the business. But the thing is, this stuff inside this contract was actually inside access control contract. It was inside this. But I took it out and put it inside this contract. And I'm using the access control, one of its redeemer, to actually handle this smart contract. So this is a proxy, a smart contract implementation. Let me little bit show the code what's going on. So if you go to the access control contract, at the top, you'll see that there is this reference UTXO management for area 1 domain. And the only thing it's doing is just checking the governor evaluation. It's just checking the governor. Does the governance okay or not? Okay, so it's not doing anything else except this guy. Is a smart contract present at the transaction or not? What is smart contract? Reference. That's reference UTXO issuer. So this checks that does this exist inside the transaction or not. So if it exists, we can, if we look at to the contract reference UTXO issuer, we can see that in each action, like issuing the gatekeeper, issuing the proxy or whatever, we are here calling this by redeemer, call redeemer, access control, get access control redeemer, RNR1 access control, ref UTXO management. So you might say, why did you do that? We have 4 different RNA, and each of them, at least at the moment, have 3 different redeeming and action about UTXO. And there are other stuff as well, like for the spending, that like how can you send in all these. And if you want to put everything inside access control, your contract becomes so big that you cannot run it actually. This is a way to just mitigate this issue. That you can put the logic of your contract inside another contract, and inside one redeemer, just calling it. But I don't know, reference UTXO issuer as a contract parameter, something constant, has access control. It is, and as this is Senate policy idea as well, because I'm inside the reference UTXO issuer in contract, I'm checking the existence of access control reference UTXO. But anyway, the thing is, this is contract parameter, but at the same time, inside the contract access control contract, I'm checking the hash of the next contract. That's the thing. If you go with the something like reference UTXO or even Oracle, you can bring some future step validation or whatever to the previous. That's a really nice thing. But maybe you don't need that. You can just comment this out. Everything will be work actually. But for the extra protection or something, you can just verify it. So the contract, this contract, as you could see here, this access control, the next contract is this guy. And this access control is like a parent to this guy. But how do we tell to access control that, hey, this is your child by that reference UTXO that we are going to build? But before that, we need to create this reference UTXO contract. It's deployed. We need to deploy it inside the treasury. We don't need to use it inside a smart contract. So we will just deploy it. We'll send that to the Republic wallet. So let's go with the third one. As you can see, the third one is create A1 area 1 reference UTXO issuer reference script UTXO. And I'm sorry again about these terms, so many reference, so many UTXO, so many things, sounds, but please bear with me. And if you just of course, if you make your hands dirty with this code, you will know it. But after some time, you will get used to it. It was very new to me at the beginning. So yeah, so okay, we created these contracts, these inside. So what would be the next step? The next step is let me just make something so it won't just close. So the next step, by the way, something else happened. I forgot to tell that. We've sent 2 ADA to reference to the area 1 reference UTXO issuer as well. Just 2 ADA with a very simple datum. This datum is 42. That's all. There is no, that's all. There is nothing else. So you can see it actually in the JSON builder here for creating JSON for reference issuer. And I call this a script activator. Why is that? Well, These are contract, but if you want to use them, they should have a role inside the transaction. And if your contract is a spending contract, you know, what are the role, by the way? So the a script per sorry, a script purpose.
Hey, Ali.
Yeah.
Where can that page you have up? Where'd you get that from? Can you drop a link to that?
This page?
No, that one where you just were. No.
What?
Where you were when I asked. All of this stuff, all of that stuff.
This guy, this guy.
Yeah.
This, okay. So when you have your Nix shell, when you have, let me show you here. This is the guy. Let me zoom a little bit. So when you have your Nix shell, run this command. It is a built-in command and it is provided by Cardano. You don't need to worry about it. Just running this, it will take time to build this documentary of this, all this page, everything you are seeing here.
Okay.
And then eventually it will fall that, hey, serving HTTP at this address, which is your address, is a loop address, but anyway, it's your address and this port. So you can just click this link and you will end up with the page. But this is the bad thing is about, if you go with exactly this page, let's just go with this link. You won't end up with the documentation. There is issue with them. If you want the documentation, everything about that, you need to have this haddock. I'm going to paste it inside chat. You need to have this haddock, add that haddock. And haddock means every function that Bluetooth Cardano is using, all the packages, it's the source code is available here. And of course, some documentation about it. It is absolutely critical. So this is the thing. Run Nix shell, then build and serve docs. Let me share this one as well. So, and then after some time, it will tell you that, okay, everything's ready. Please go to this website, but don't go to that website. Go to the haddock one. And there you have everything ready here.
All right, thanks.
Great. So we have something called script purpose. Script purpose means right now at the moment in Cardano, all the contracts can play 4 rule. That's all. They cannot do 5th, they cannot do 3 or something. That's a 4 rule. And not all, not like for example, okay, let me. They're all on minting, spending, rewarding, and certifying. Minting, of course, the name suggests it's minting. We will mint tokens. We will mint stuff with it. Same thing happened with ADA. So there was some Genesis contract, Genesis minting contract, and which minted ADA. So I would love to see it one day. That what was that exactly? But
there was a contract because ADA has the currency symbol empty byte string, and it's just empty currency.
But there was a contract, Adrian, or there was some code like.
I think it wasn't a contract.
Oh, okay. So yeah, ADA and it's a good
script.
Sorry.
Else we would have a minting script, but if it's the empty.
I wonder before that at the Genesis they made some contract to do the minting for ADA or no, they just put it there because there was some minting. I mean, at least this is my hypothesis. There was some minting and then there was some sending. They sent some amount to the teams, to treasury or something. So I wonder what happened at that big bang. So I don't know, but as Adrian is saying, yeah, maybe there wasn't a minting contract. The minting contract, by the way, a minting contract, what we are seeing here, of course. But there was a process to mint ADA. And as Adrian mentioned, that the currency symbol and the token name for ADA is both, the token name is empty string, Adrian, also? I forgot just, yeah, I think, right? So I think here, let me say ADA symbol, yeah. ADA symbol and ADA token, both of them are empty string. Where is it? Yeah. ADA token name, empty byte string, ADA symbol, currency symbol, empty byte string. And you cannot create a token that's portable. You cannot even submit it. I mean, if you can, but you cannot mint it. And the protocol doesn't allow you. You cannot mint a token with this characteristic, like empty byte string or something. You cannot do that. And there is no any burning. But interesting thing, inside Cardano, unlike Ethereum, every token is a native. So every token, when minted, it would be actually equivalent of ADA and token. So the thing is, one of the things, again, in regards to the question Erez asked, the voting, if Cardano come up with a very good, nice voting system for the whole blockchain, and its token, it's the one at the heart of this system is ADA, any DAO inside Cardano can use that as well and put their token instead of ADA. Because of this, I mean, this is well thought, by the way, really, this is the research-based, well thought stuff that they said that let's do something so people can replicate it with ease inside the blockchain. That's the thing. So all your token, whatever you have, is exactly the nature, it's same, just here other as by empty byte history. And we are so if future voting system in here, we might implement some token, some stuff token, and we might use ADA. We will decide what. Yeah. So yeah, script purpose, as I was saying, for contract can do 4 things, but minted contract cannot do a spending. A spending contract cannot do a minting, and rewarding as well. Rewarding is for withdrawing your stuff from the stake, like ADA or whatever, from the staking pool, and certifying is for staking your smart contract to a pool. So I want this smart contract here, this reference issuer contract, have a plain role, right? I want to use it, but I don't need any UTXO from it. I don't want to send something there to do something, okay? But since it is a spending contract, it must do a spending. It has to do a spending. Therefore, inside the transaction, we can see it, we can use it. That's why I sent the 2 ADA to this address, just doing that, bringing this smart contract to the table, the transaction table. And that UTXO will be there until all the reference issuer is done. And then there is this very restricted rule that you must send this UTXO back to the treasury, back to the Republic Treasury. So that's the idea. Inside the script, you can see that I have this TX out. So this is okay. This is the one that getting error on. But so you see that there is this 2 TX out. One is go for contract, and one goes to the. I mean, one goes to the contract. One goes to the contract, which is this one, to the reference issue, to the reference UTXO issuer contract with this datum, which I show you is 42 simple. as a 2 ADA. Why 2 ADA? No reason. 10 ADA, 1 ADA. It is just a roles script activator, call it. And another TX output will go to the Republic Treasury. So this happening here. And we are going to see this UTXO in future, this activator UTXO in future script. So this is the thing that there is 2 ADA that's going to be sent to the reference UTXO issuer address. So in the future transaction, we can bring this guy to the table. But by the way, we do not spend it. We will send it back to the address. We will send it back to the same smart contract. We will not change it, send it, nothing. It is just for activity. It's just something. That's all. So let's go for the 4th one. Okay, this is not the one. But if you guys have any question, please feel free to ask. Or if you do not have any question, if you want to like swearing, like releasing your anger in words, just feel free again to do that, no problem. So the 4th script is the access control reference UTXO with reference script. This is the very, very crucial step in our process. And so the idea is we are going to create reference UTXO that the whole DApp, all of these gatekeeper, whatever we are, all these smart contracts going to use it as a reference. This is like a golden UTXO. Let's call it that golden. So how do we create it? So, okay, we have this reference UTXO data, which I show you. It was consist of addresses for treasury, hashes for other small contract, and so on. And then there is this Senate as well. Why? Because as I said, I should put a token inside this authentication token inside this UTXO. And the token, the token name is access control script hash. So the hash of access control will be that token. And the currency symbol comes from Senate. Therefore, by combining these information, other smart contract can use this information for their validation. Like they can use the token name of this authentication token to know who is the access control. So even I showed you that inside the compiler, you have to have these access control validator hash as your contract parameter. Actually, you don't need it. I haven't implemented, but well, you don't need it that much. You can have a contract completely free. Everyone can use it. So actually, this system can be so generalized, everyone can use them. Everyone can use this access control, authentication token, whatever, they can use them. Any DApp, there is no any restriction. And they can send these UTXO inside them. And your DApp in front end can recognize them based on all these authentication tokens. Authentication token for admins, authentication token for a smart contract, authentication token for reference UTXO. So maybe that's a good plan. I don't know. I'm just sharing with you guys that we can have very generalized contract that everyone can use them. And we can just go with this authentication stuff. I don't know, maybe we can discuss about that. This is a good plan or not. But anyway, that's a thing that in the 4th script, we are going to see that I'm going to use this access. By the way, this access control usage is just the hash of inside the environment config. Let me remove this temp. Also test here. Okay. Inside the environment file, you're going to see that there is a line 231, access control reference UTXO authentication token. And it is consists of Senate policy ID and access control script hash. But you might wonder, how the hell did I get a script hash of access code? It is a spending. Well, we are already breaking a stuff. We are already using the Cardano for something that was not supposed to use in that way. By that, I mean, so there is a command here. There is this command, Cardano CLI transaction policy ID script file. This is normally, you can use it, generally you can use it for getting a policy ID, for a minting contract, for tokens, for a stuff with NFT and so on. But I use same command for a spending contract. You can use same command for what? For rewarding, for withdrawal, because policy ID, currency symbol, script hash, all of them are same thing. All of them are same thing. Policy ID, let me repeat. Policy ID, currency symbol, script hash, all of them are same thing. Therefore, I'm using this command for a spending, getting a script hash. But exactly I use this command to get policy ID. So don't let these names fool you. You need to actually remember this term, that all these are same. They are just a hash of this contract. At top, there is this, not the hash of this guy, I mean the hash of this, actually the hash of this guy. It is this one. Where is this from? Wrong type. If I remember correctly, by the way, I forgot. But the hash was like here. If you remember, when you compile this, it shows that a script hash. I just now forgot. This hash was coming from the CBOR or the actual Bluetooth core. I think it's actual Bluetooth core. But anyway, this is a hash of your contract, which you can use it as a currency symbol for NFT. We can use it for policy ID for a token, authentication token. We can use it for something else. That's it, just a hash of the contract. And okay, let's see, I got something in the chat. So let's run that command, but maybe we can just see what's going on inside the transaction. It's transaction. So the thing is, we have decided to have 7 senators and 1 Caesar. In order to designate the governor, all of the 7 members of Senate must sign this transaction, must be agree with it. Also, Caesar must be agree with it. This is the like the system that we design. Is it bad? Is it good? Let's decide. Let's talk about it. We can't talk about it. It's bad. I don't know. But this is the system. So as you can see, there is this, at least 8 people are signing this. And this is, again, designating not the governor event. It is for a reference UTXO. So reference UTXO is important. It's a government, right? We say that there is a government, there is this reference, which is kind of a software for the government. Like this is this access control, let's say the hardware of the government. There is something comes and sits over it as a software, which is the reference UTXO. And there is a governor who is govern this stuff. So these 3 entities must have these this Senate and Caesar must be agree with that. So they should say, okay, we are agree with that. Therefore, here all of them are signing this transaction. And it is again same thing as I said. There is two same command to get that minimum amount for the contract because the reference UTXO, oh, take care, Dan. See you. So the reference UTXO is going to have reference script as well. So let's just run this. And so as you could see that for minting contracts, we needed less ADA, like 11 ADA, 12 ADA. But as access control, because it's bigger, we need 29 ADA. But it is not just that, because there is authentication token inside it as well. So remember, if you want to put this system, you need to have this ADA in your wallet. And you see that fee is kind of expensive, 625,000. Lovely is expensive, but it's at least it's a one-time payment cost. So you don't need to do that again and again. So yeah, we just created reference script with reference UTXO with reference script. Actually, I'm going to query that and say this is the access control address. This is access control address. Let's just query that and see that UTXO we just sent it to there. But I hope it's landed there already. Let me check that. Let me just check that. Is it there or not? Yeah, it is. You see, this big UTXO is going to be or suffer for government for now, at least for this system. And this is the authentication token. This part, this first part before this dot is Senate policy ID, aka Senate contract hash. And the second part is actually access control script hash. And there is this datum, which is the reference datum. But there is something else inside. Let's look at it. Dash out 5 temp. Let's again cut the temp. See, there is this. That UTXO you saw, this guy. If you expand it, it will be this guy. That there is this, as I showed, there is this field. These are the treasury addresses, and there are these hashes for contracts. And of course, there is this reference script field of access control. So we have sent the same contract inside same address, same contract address. And we are going to use it, and sure, we are going to expand that as well. And that's the thing. So this is the big UTXO. This is the golden one. This is the one that I said that we are going to see that if Caesar expanded or something happened, okay, it's like a government collapse. So, or like the government doesn't have functional people there. So let's go for the fifth one. Fifth one is designating the governor. You say that there is this governor. And again, if you look at the bash script of that, everything is similar. It's again, every senator must be, I agree with this, also with Caesar, but it holds a datum, which I showed you in this here, that the governor has an authentication token, which again, at the policy ID Senate, but the token name is the pop cache of the same guy, same governor. Is an ID for this guy. Everywhere he goes, he shows this ID. Hey, I am designated, I am issued from this Senate. And that next part, which is the token name, it is my identification, it is my pop cache. And this UTXO holds a datum, which is like a pop cache session. And you might say, why this again pop cache here? Okay, there is issue with some logic with the contract. We can improve it later, but right now we need the pop cache inside the datum as well. But if we have less datum, we can have less UTXO and less even transaction fee. So that's actually better to remove the stuff. But anyway, this is the stuff there. Right now, the session doesn't matter because I just commented that out all the stuff regards to the session. Yeah, this is so don't worry. So, but this is we can talk about the session. How long a governor should be a governor, and then what will happen? Yeah, that this is and I just sent UTXO with 2 ADA. Why 2 ADA? That's just number. Actually, maybe one like 1 ADA 0.3 something would be enough, but I said just with 2 ADA. I mean, as a simple number we can remember. With access control, to send into access control address, you are sending that guy to the government building, the hardware, and with the authentication. And again, this is a bash. Okay, that's nice. I didn't know it can show me here, but as you can, if you have this beautiful extension, which I don't know which is, you don't have it, of course, be jealous. So this shows that where it was defined, and it's defined inside the environment file, and here we can see that where is this called? Access control governor authentication token, which consists of Senate policy ID as a currency and the governor payment public. Sorry? Roberto? Okay. So this is just that's all. And I'm using the same reference as a Mint reference. I'm using the same contract, same deploy contract that UTXO that we send in Republic Treasury as a contract provides. So I can provide the contract to the transaction. This is the thing, and we can go to detail, but anyway, so this is like a designation redeemer. Okay, so yeah, this is the thing. But again, it's kind of similar to the issuing the access control reference script. We are using the same redeeming and same stuff, but it's kind of a designation. So it's not that much difference. But so let's run this, and let's then after that the phone actually maybe the real phone begin. So you see that's again everything's completely automatically is done, everything is there. We can see that yeah, there was this this is again access control, and if we let me just query the access control address to see that this guy is there. No, it is not there. So let's query that until we see that it is there. So then I think let's wait a little bit. Okay, so until this UTXO comes to the access control address, let's talk about the next step, most complex step I can think of. So this was the 5th step. Senate governor data will send it to access control. Okay, this is the 6th one. So here, what's happening? We are trying to create an gatekeeper reference UTXO, which has gatekeeper contract as well. That's CBOR you saw, that reference script. So in order to do that, you see that we are having this headache. So we want to authenticate that UTXO to the smart contract afterward of that and to other domain event. So we need to use area 1 domain authentication token. And again, it would be same as the access control. The currency symbol policy ID will be the A1 domain authentication token, and then the token name will be the hash of gatekeeper, the hash of the contract. And then by use of access control, because you saw that there is this ready-made access control, government is going to decide and designate this stuff. But we are going to use governor and access control reference UTXO as well. because governor is going to use this information and using this contract to issue this reference UTXO. Governor is the one that doing that. But by the way, we are seeing that we will use a fund of treasury, but the person who is going to witness this, who is going to sign this transaction, is actually the governor. So, and as you can see, this is data. I put this cylinder as a datum. So I'm going to RNA1 gatekeeper reference UTXO datum. And I will bring this contract reference UTXO issuer with its activator. And then by if everything is fine, we will have everything ready to send, to create reference UTXO with reference script and send it to the gatekeeper. So let's do that. But you might notice that there are 3 versions. Why is that? Because there are some differences there that we are going to discuss about it. So the first version, in order to, for your transaction, at least in Cardano CLI works, you need to use this switch, at least for first version. And we are going to go through the other version. Read only TX in reference. By providing that, and front of it, of course, this access control reference input, you will bring UTXO as a witness to this transaction. Take care, Roberto. Take care. By the way, we are past 2 hours already. I don't know, guys. If you guys, you want me to continue, or do you want me to just close it? Well, I don't know. James is here, or I think maybe he left. So I can continue. I can just, we can see just what's happening. Anyway, so the read-only UTXO, and you need to provide that. And you see that this is big. Let me little bit show it. There's around maybe 30 line of the commands. All these stuff happening inside that, because there are many things. As you could see here, there are 3 contracts coming here, 3 contracts, and we have reference UTXO as well. We have activator, we have governor, we have datum. So there are many things happening inside this transaction. And but let me just run this and see what happens. I think, by the way, this lands here. Yeah, as you can see, this 2 ADA, this governor token to governor UTXO is landed here, and it holds this authentication token as well. So let me run the 6.1 script. Sorry, I should have made this here. I can take this time. So this is, I changed the canonical order. So for the token would be better. So I forgot to change this stuff there. Is it 3? Okay. So yeah, version 1. And it will take the treasury to build its utility. We are going to use the treasury funds to do that. Okay, we got an error. So what's an error? I think I know it, but anyway, TX out. Okay, yeah, I think the error is I'm going to do it, but the thing is, we are going to use the Republic Treasury for building that.
Got the ADA value, I think. If you scroll.
No, the issue is in the first version, Adrian, I'm using the I wanted to use a reference script. I mean, a different UTXO for reference script, not the one that we built. So there is this another contract. There is another script, bash script, that will create for you the access control reference script and send them back to the Republic wallet address. It is just an same thing, same as other script that we saw, like the Senate, the A1 DAT and A1 Ref UTX issuer, the same thing. And so this, because this is the usual way. The usual way we were used to is deploy your contract, send that to a wallet, and reference that or bring that UTXO in front of it, front of this switch. And yeah, this is the instead of a Bluetooth file, use this UTXO. That's the usual thing. So I just forget to do this as well. So let me just run this. Create access control reference script UTXO. So yeah, this will create same reference script we built, same thing. But without that datum, without that reference UTXO datum, and it will be sent back to the Republic Treasury wallet. That's the only thing. That's the only job it's doing. And the only job is doing is because, as I said, because I wanted to show you this is the one. But in other version, we are going to see that here I use. Let me show here that I'm using, as you can see, it is. If I highlight this guy, it will be highlighted here as well. So I'm using same reference input, same reference UTXO as my reference script as well, as my same reference contract as well for to using that contract inside the transaction. This is new. This is the one that we are going to see, and we are going to see what happens if we do that. What is the benefit? And if we again go to this 6.1, here we see that the reference for this switch and here are different because this comes from a wallet. This comes from a smart contract. So just let's again run that and see if this was the issue. I hope. I guess that was the issue, but let's see that. Yep, that was the issue. So we just created that gatekeeper reference UTXO, which consists reference script for gatekeeper as well. But just let's take a look at this transaction hash. I'm going to use Cardano Explorer. Cardano scan? Cardano Explorer, Cardano scan. Cardano scan, sorry. Or yeah, Cardano scan. I'm going to paste that transaction hash. I hope it will still we need to wait until the submission and verification or something. Cardano scan is a good place to investigate about stuff there. Okay, so let me just but you see that the TXV is high, it's around 800. But let's remember that. I mean, actually, let's do this with other pages. So let's keep it there. Let's run this script in other page so we can compare stuff there. Let's see that does this land? No. So guys, if you have any question or something, please you have at the time. I know again we passed a long ago from 1 hour 30 minutes. This is the issue that you guys when asked about philosophical question or some question, we will talk about this stuff, but it's not that one. So technical, and unfortunately, this thing doesn't. I mean, I don't know where they are. Go ahead. Go ahead.
You're on minute. Do you check on pre-prod?
Oh, yes. So yeah, exactly. That's the issue. Thank you, John.
And it has been a bit slow today. I was doing some tests with Crispus, and we also had some issues with the transactions.
Thank you. You know, I otherwise I would have stuck here and just refreshing and trying to find
Yeah.
something. But yeah, it's there are some tests happening maybe today, as I
Yeah.
heard some. It's not here even. Well, at least it is much. I mean, it is purple, so we will see that. Oh, okay, it came. So let me share this link with you. You can check with me as well. So this is the thing that happened here. That is a script did here. But what let's look at what the hell happened. What exactly happened here is you see that we have this let's say the summary. The summary doesn't help us UTXO. So we have 3 UTXO coming to this game, to this play. 1 UTXO coming from the smart contract. That 2 ADA. It is coming from what? From access control. This is the access control. This is the 2 ADA of what? The governance. The governor UTXO is coming there because we are going to use it and again, you know, recreate it, spend it and recreate. That's why it's here. And then there is this UTXO that's coming from the wallet. This is 29,000 something. And this is a script activator. It's coming from reference UTXO issuer contract. So this is the 3 UTXO. But I showed you there is a 4th one. That one, since we use it as a reference here, it will come at this tab, reference input. This is the one, sorry. This is the one, this is the one. This is a reference UTXO, and you can see it consists of a smart contract and a data. And we can inspect that data. And this tool inside Cardano Scan can decode this guy. After decoding, we'll see that, oh, this is the thing that we were seeing here. We were seeing here inside this repo several times. So you see this, when you have this reference guy, since you do not spend it, it won't end up here. It is a UTXO, but you do not spend it. And you can see that we have used 3 different contracts as well. They are coming here as well, reference, right? So this reference input is a tab that you need to look for these references stuff. And of course, in the contract tab, you can see the more details about contract, what happened, what stuff actually they share. And there was a token mint, because as I said, there was this authentication token for Gatekeeper. There was a mint happening. And policy ID, this is the Senate policy ID. And there is this collateral, which is the collateral. It's nothing so that much special. But if you have any question about this, Steve, because Steve, do you have a question?
No.
No? Okay. Okay, so let's run the second version. Now the second version, if you guys remember, I'm going to use the same UTXO from the contract, from the smart contract, same UTXO that was used. Its datum was used, and to be used for a spending TX reference. So to be used as a contract reference as well. So I can use its SQL hash. So let's look at what will happen with this. Let's see that this is the old one. Let's run this one here, so we can compare the stuff there. You see that this reference script, this reference UTXO is same. Look at the TX hash. We had a transaction, but that guy didn't spend this, didn't update it. It's just the reference, just use it as a witness. Here, this is, you see, this hash for this big guy and this hash, they are same. So you do not need to spend it. Look at the fee, 829, 511. This is expensive. If you use this new method, at least around 30 something thousand Lovelace, it would be even beneficial for your DApp in the terms of the fee, the transaction or something. So it would be better to use this reference UTXO as a reference script instead of wallets, instead of using that like the wallet. This is Republic Treasury. A fee is smaller, but let's take a look to the hash as well, the transaction hash. This is what happens. So.
Hey, Mix, I know you offered to record at the beginning, and maybe you should have, because I have to jump out of this.
So, okay, let's actually finish the session. So, because we will continue that in future, but this is the thing that I wanted to show you. Please check out this guy, and if you have your question, but this is the heart of the stuff that you can use this reference script as your reference UTXO as well, and your DApp become cheaper. And another thing before wrapping everything up, this is a proof that can, this is a proof to show you that the whole blockchain, whole Cardano, everything you see here as a UTXO, all in here, there is this blockchain contracts, all these stuff here, all these UTXO, you can use them inside your DApp. You don't need to spend them. You don't need to ask permission from them, nothing. You can just take whatever you want, those information, its datum, its content, its script hash even, and use it in your DApp if you need it. So yeah, this read-only, this reference UTXO can unlock a lot of stuff. And by using this, we are going to implement that voting system, whatever it is, bad, good. We are going to use this stuff so much time. So don't worry if you didn't understand that right now. I didn't even, I didn't even at the beginning for several days, even I didn't understand what's going on. So yeah, thank you for being here. Thank you for listening. And again, I will post the links to this repo, everything into description. And if you have any question, please type me on Discord. So yeah, thank you very much, and see you. I hope next week. If not, we will inform you that the 2 weeks from now we will have the next session.
Happy New
thank
Year.
you for being here. Thank you.
Yeah, I'll be thinking all weekend about how we break this down into bite-sized pieces and really onboard people towards this. It's so exciting, man.
Yeah.
So good.
So thank you. So yeah, take care, everyone. See you around.